Right, so we're going to look at finding the exact value for each of these different trig expressions. So the first thing to identify here is that the values in the angles are much bigger than 2 pi, or even here this is a negative, but it's still bigger than like going around backwards 2 pi. So we're going to look at first of all 11 pi on 4. If we think about what 2 pi is 8 pi on 4. So let's think about what this would be expressed as. It would be 8 pi plus 3 pi. That gives us 11 pi, each of those over 4. So 11 pi on 4 is really 2 pi plus 3 pi on 4. That's what this angle really is. And when we think about the unit circle and trig, sine and cos, wherever you've got an angle, say theta, your sine and your cos are going to be the same whether or not you go 2 pi around, which gets you back to there again, or 4 pi, or 6 pi, or 8 pi, or also if you go back the other way. So you can go backwards that way too. That would be negative 2 pi. You still end up back where you started. So this is actually going to take away a bit of work for us because we don't actually have to pay any attention to any multiples of 2 pi in our work. Let's look at this angle here as well because it's going to simplify our work for us. Negative 23 pi on 4. Now I think about multiples here of 4. So 5 times 4 is 20, 6 times 4 is 24. This is pretty much very close to 23. So I'm going to break this down. 6 times 4 is 24 pi. Let's think about this as being negative 24. That's really close, but it's actually plus 1 more pi on top. Let's do those over 4. Negative 24, that turns out to be a nice multiple of 2 pi. It's 6 pi. Okay, I'm just going to write under here. That's a multiple of 2 pi. And we've got 6 pi here plus pi on 4. So again, we're going to be able to actually ignore this 6 pi here. Or I should say negative 6 pi. Okay, multiple of 2 pi, just going backwards that way. The last one, 11 pi on 3. Let's do the same thing. 11 pi on 3, I think about again my multiples of 3. 3 3s are 9, 3 4s are 12. There's a couple of ways you could do this. I'm actually going to build it up to be close underneath. So 3 3s are 9 pi on 3, plus 2 pi on 3. Now what you'll notice here, this doesn't turn out quite so nice because it's 3 pi. And because it's 3 pi, it's not a multiple of 2 pi, this isn't going to help me. I can't actually ignore this, so it's not a multiple of 2 pi. So what you want to do is think about this again. Can you rewrite this so that you do have a multiple of 2 pi? Let's go too far past 11. So we'll go 3 times 4, which is 12. So let's go 12 pi over 3. And let's take away a pi. So 12 minus 1 is 11. 12 pi on 3 is 4 pi. That's nice because that is a multiple of 2 pi. So we're going to be able to ignore this. And so now what you can see, let's actually get started. We've got sec of 11 pi on 4. That's the same as sec of, over here, 2 pi plus 3 pi on 4. Now because of the unit circle and the way that our angles are working here, this just means that we go round back to 3 pi on 4. 3 pi on 4 and then we go 2 pi back to the same place. So we can ignore this. This is really just sec of 3 pi on 4. Remember that sec is 1 over cos. Look at that third letter. And using your triangles, the 45-degree one, which is the pi on 2 triangle, has root 2 on 2 and 1. Pi on 4, excuse me. So the 45-degree triangle. So this 1 on cos 3 pi on 4, cos of 3 pi on 4 is going to be root 2 on 2. So it's going to be 1 on root 2 on 2. 3 pi on 4, I always think about this as a picture, is going to be here. So cos is actually negative. All right. Because this is 1 over a fraction, 1 over anything flips it over. So our answer here is going to be sec of 11 pi on 4 is equal to negative, flip this over, so the 2 is on the top, 2 on root 2. And because you want to give this expressed so that you don't have the square root on the bottom, multiply the top and the bottom by the square root. So your final answer is negative 2 root 2 on 2. Nice cancelling, which actually cancels down really nicely to negative root 2. That's all that's left. So sec of 11 pi on 4 is actually just negative root 2. For the other two, I'm going to do those just like that. Get my blue pen back. Alright, so for sec, or cosec of negative 23 pi on 4, this is the same as, remember cosec is 1 over sine as well, but this is the same as cosec, and we found this out here, of negative 6 pi plus pi on 4. Remember that any multiple of 2 pi just gets you back to where you started, so round, back to there, round, back to there. This time it's just going the other way, but it doesn't change the angle, so we can effectively ignore that. We just have cosec of pi on 4. Cosec is 1 on sine, that third letter. And let me just erase this under here. Sine of pi on 4, again we're going to be using the same triangle, sine opposite over adjacent. Oops. 1 on root 2 over 2. And think about where we are, unit circle. Before we were at 3 pi on 4, this time we're actually at pi on 4, which is over here. And you can see that the sign is positive. So this is going to be a positive answer. So therefore, again it's going to be flipped over. So cosec of negative 23 pi on 4 equals this fraction, because it's underneath 1, flipped over. So 2 on root 2, which we know from our working over here, 2 on root 2 ends up being root 2. So the answer to that one, cosec of negative 23 pi on 4, the answer is root 2. So to finish off the last one, we know that 11 pi on 3 is the same as 4 pi take away pi on 3. So that's for C, for cot. That one there is B. So for C, cot of 11 pi on 3 equals cot of 4 pi minus pi on 3. Remember that any multiple of 2 pi just gets you back to where you started. So we can ignore this. So what we've got then is cot of negative pi on 3. Remember that cot is 1 over tan, so this is actually the same as 1 over tan of negative pi on 3. So thinking about where this is, negative pi on 3 is there. Tan is going to be negative here, so we're going to have a negative answer. And I'm just going to draw quickly a very useful triangle, root 3 on 2, pi on 6, pi, on 3, it's a bit dodgy that pi, and 1. So tan, opposite over adjacent, this is going to be 1 over, this is going to end up being root 3, okay, root 3 on 2 on a half, which just ends up being root 3. But if you want to see all the working, with fractions, I always do the two middle ones together, the two top ones, top and bottom together. So you're going to end up with 2 root 3 over 2, and your answer is going to be 1 over root 3. So for this one, I should always remember too that our answer is going to be negative. So just let me get rid of this part here. So for this question, and I always at the end rewrite the question with the answer. It's just really good practice to do that. Cot of 11 pi on 3 was 1 on root 3, and our answer, because of the quadrant it's in, was a negative. So our three answers, sec 11 pi on 4 was negative root 2. Cosec of negative 23 pi on 4 was positive root 2. And for cot 11 pi on 3, our answer was negative 1 on root 3.